All right. Hello, everybody. Welcome back. We're going to pick up where we left off in Section 1, Unit 1. And we're going to focus right now on counting atoms. All right. So, if you have not, make sure you have your green sheet out and ready. We are open to page 3. I'm going to start about halfway down the page where it says counting atoms. All right. So, let's start it off. So, water. H2O, which is its chemical formula, is a compound composed of elements hydrogen and oxygen. There we go. So, and you might have been thinking in the last video, all right, Mr. Raff, I understand the letters and the symbols and the formulas, but then you threw in some numbers and I was kind of confused. So we're going to break down what some of those numbers mean. Help clarify it for you for a little bit. So, when we have one H2O molecule, you want to think of this as, right, this super small, right? Not even with the microscope will you be able to see a molecule. This is going to have 2 atoms of hydrogen and 1 atom of oxygen. All right, so we want to notice, I'm going to move this out of the way just a little. We want to notice that the subscripts in this formula will tell us how many atoms we have of each element. So we see here that there is a 2 after the H, so that means there's 2 hydrogen atoms. After the O, there is no number, right? And that is the same thing as there just being a 1, right? If there were no O's, you wouldn't see that letter at all. So if you see an element in a compound or by itself that is not followed by a subscript, right, you can assume that there's 1 of that element or atom. Let's see here. All right, now coefficients, on the other hand, are the big number out front. Okay, so subscripts are going to be our little numbers following the elements, but before our element or compound, sometimes you will see a number, and that number tells us how many molecules we have. All right, so we're going to do a little bit of practice together, and then I'm going to give you some practice to do on your own. So let's take a look at our first one here. And we have CH4, also known as methane. Okay, when we go, we want to start by seeing how many molecules we have for each element or compound. So we're going to be looking at our coefficient. Our coefficient should be found in front of our compound. I don't see a number there, but remember I said if you don't see a number, that means that there is 1. Right? If there were 0, we wouldn't see anything. Okay, so if you don't see a number, you can assume it's 1. If you do see a number, we're going to roll with that number. Okay, now we're going to take a look at our atoms. Right, finding the amount of molecules for this one was easy. So when we're counting our atoms, we want to start with what elements or what different atoms do we see? Well, I see we have a C and an H. So we have C for carbon, and we have an H for hydrogen. Okay, I see that I have only 1 carbon. Okay, there's no number here, so we can assume it's a 1, and I see that I have 4 hydrogens. Okay. Sometimes we might have more molecules. So I'm still going to show this part. If we want to find out the total number of atoms, we need to multiply that by how many molecules we have. Since we only have 1 molecule of each, that's not going to change, right? So we'll end up with, we have 1 carbon and we have 4 hydrogens for a total of 5 5 atoms. I'm sorry, I'm still getting used to this pointer for writing, so hopefully that did not throw you off. We're going to try, I think I know what I did. We're going to try it a little bit better on the next example here. Whew, so this one looks crazy. So we have 2Na, 3PO4. Alright, well let's start with how many molecules I have. So for molecules, I want to look at my coefficient. My coefficient is 2. So I have 2 molecules. And obviously, I did not figure out what the problem with the pointer was. Alright, so when we count our atoms, we want to first identify how many different elements we have and what they are. So I can separate this into, we have Na, P, and O. These are my different elements. We can tell because each capital letter tells me I have a new element in the compound. So we'll start with sodium and A. We also have P, which is phosphorus, and O, which is oxygen. All right, so how many do we have of each? I can see here, right, in my subscript that I have 3 NAs. Again, I'm sorry for those horizontal lines. I do not know where they're coming from. All right, when I'm looking at P for phosphorus, I do not see, right? I don't see anything there. So, if you don't see a subscript, we're going to assume that is the number 1, right? If there were none, it just wouldn't be there. And for oxygen, we have the subscript 4, so we have 4 oxygen atoms in this molecule. Now, remember before I said we're going to have to multiply how many molecules we have. So we do have 2 molecules, so we have to multiply each of our numbers by 2, giving us 6, 2, and 8 for a total of 16 atoms. Alright. Let's try one more practice together. Oh boy. Oh man. This one looks tough. But I think we can do it. Alright, so first thing we want to identify is how many molecules we have. We're going to look at our coefficient out front. I do not see a coefficient, so we're going to assume there is only 1 molecule present. Okay. Next, I see I have Al. This is not Ai, it's Al, which is a symbol for aluminum. So we have aluminum. I also see we have 2 other elements. We also have an S and we have an O. The S stands for sulfur and the O is the symbol for oxygen. Alright, so let's figure out how many atoms of each of these elements we have. So I see we have 2 aluminums, right, found by our subscript, the small number down at the bottom. Now, what is going on with the S and the O? I mean, I wish there was somebody here to help me, but I'm all alone. So let's try to figure this out. I see we have parentheses here. So you might remember in math class, when you see parentheses and you're multiplying with a parentheses, you need to distribute. All right, so what we're going to do is we're going to distribute this 3 that's outside the parentheses to each of the elements inside the parentheses. All right, and we're going to be using multiplication. Okay, so right here, even though I don't have a subscript, we know that means I have 1 of those atoms. And of course, we had to have a horizontal line. That was sarcasm. We don't actually need to draw horizontal lines here. I'm just having issues with my pointer. So if I have 1 sulfur, but I have 3 outside the parentheses, it's going to give me a total of 3. All right, and now when we distribute this 3 into the oxygen, that gets us 12 oxygens. Remember, when we are distributing a subscript from outside the parentheses to the inside, we are going to be using multiplication. And then in order to find out our total number of atoms, we can add all of these up for a total of 17. I did not do the multiply by the molecules because we only had one molecule. It would have been the same number. There is more than one way that you can do this. If you go a little bit out of order, you can still get the correct answer. So let's take a look at our second one. If instead of multiplying each one of these by 2, if you wanted to add them up and then multiply by 2 afterwards, you would still get the same answer and it would still be correct. All right, so that completes our practice on page 3. All right. I am sure your excellent chemistry teachers, myself and Mr. Arrow, have assigned some practice work for you on pages 4 and 5. So let's give it a go. I'm not sure if we assign odds or evens or page 4 or page 5 or just all of it because we are mean, nasty chemistry teachers. But get to work on that and we will go over it when we see you back in class. Have a wonderful night. Thank you for watching this video and staying on top of all your chemistry work. Adios.